Greetings to all those present. Special thanks are due to the Housing and Infrastructure Board that has allowed us to develop the design for the new city of Sidi Al Hamri, and to the CMCS with whom we have defined the strategies that have led to what we consider an important project. The presentation will include two chapters: the features of the area where Sidi Al Hamri will be developed and the phases of preparation of the project. The complexity of the project doesn't allow to describe all the single parts of the whole design in few minutes. Therefore, if necessary, we will describe in depth the specific topics that make up the design of the new city of Sidi Al Hamri. Features of the area where Sidi Al Hamri will be developed. The area of the new city is located on the Green Mountains, 15 kilometers south of Al Beida, 30 kilometers from Shahat, and north of the road from Benghazi to Darna. The area is mountainous. It slopes down towards the north and is crossed by a series of valleys developing from south to north. The elevations range between 730 and 830 meters above sea level. In the future, it will be served by the railway. The area is 35 kilometers far from Labrak International Airport. The climate is temperate and is milder than the rest of Libya. In summer, the average maximum temperatures rarely go over 29 degrees Celsius. This allows the natural ventilation of buildings. The winter temperatures rarely reach 0 degrees Celsius. The Green Mountains are subject to high levels of solar radiation throughout the year. The prevailing winds are the northern ones blowing from the Mediterranean. The periodic winds are locally known as Kabil. The rainfalls are prevalent during winter months and reach between 500 and 600 millimeters per year. From the geological point of view, the area is defined karst. It is located within a seismic area classified as Zone 4, with a degree of seismic activity Sk equal to 0.05. The Green Mountains area shows a significant percentage of particular plant species, thanks to both the unique physiographic and climatic conditions. Sidi Al Hamri project. The area of Sidi Al Hamri city wasn't built and was intended for grazing. The first project of the city followed the planning and urban criteria normally used in Libya. The city had to include about 7,000 housing units, in addition to public buildings and services, and covered an area of about 860 hectares. In March 2009, the construction of roads, of the fence, and of the wells for the supply of water started. In May 2009, the authorities decided that the new city had to be completely redesigned and expanded up to 995 hectares, and it had to be the first example of application of sustainability criteria. Sustainability is a continuous process that recalls the need to combine the three basic and inseparable dimensions of development: environment, economy, and social. Complying with these three dimensions, the humankind has the possibility of having sustainable development meet the needs of the current generation without compromising the needs of future generations. The project for the city of Sidi Al Hamri was developed in compliance with sustainability criteria, following 6 phases that we are going to explain. The first phase concerned the topographic, geological, archaeological, and geoelectric surveys. The planimetric and altimetric survey performed with the GPS and connected to the Libyan topographic network. The archaeological survey, carried out together with the technical staff of Shahat Archaeology Department, found 31 sites. The preliminary geological survey, that included drilling, soil resistivity tests, soil penetration tests, and lab tests on the collected material samples to discover the mechanical, physical, and chemical properties of rocks. The tests on underground concrete didn't show any corrosive potential. The accurate geoelectrical survey, still to be completed, was necessary to identify the presence of any underground cavities in the areas involved in the construction of buildings. The second phase concerned the design of the land use and of districts' master plans. In agreement with HAB and CMCS, the preparation of the second master plans project was in compliance with some basic principles that contribute to make the project sustainable. We are going to describe them. The first principle is the adjustment of the project to the topography of the ground. For example, the roads and the buildings follow the layout of contour lines. The public buildings are at the center of districts, and so on. The second principle concerns biodiversity, or the protection and preservation of the environment and of natural areas. For example, the natural areas between districts and the landscape views without buildings were kept, and so on. The third principle concerns the clear definition of public spaces, roads, squares, playgrounds, gardens, parks, parking spaces, and so on, common spaces, condominium areas, and private spaces, the areas pertaining to single-family houses. For example, the roads were defined and designed according to a hierarchy of use and were linked together to create an interconnected and permeable network of roads. The fourth principle concerns the integration of the city center with the rest of the city and its position in relation to the general services of the city: hospital, railway station, urban and extra-urban bus service, and so on. The barycentric position allows the residents to walk or to use public transport without moving private cars. Sidi Al Hamri's city center is formed by 3 districts: 5, 6, and 7. It was thought as a wide and paved pedestrian area oriented from west to east, with 2 wings of buildings along the northern and southern perimeter that create shaded zones, allowing pedestrians to enjoy the area also during the hot and sunny season, and protect the pedestrian area from the northern winds. The railway station is not far from the center to the south and can be reached going along a boulevard, where the buildings are provided with arcades, and along a walkway that passes over the road from Benghazi to Darna. The stations for the urban and extra-urban bus service and for taxis are located to the east of the boulevard in District 4, between the city center and the railway. The fifth principle concerns the identifiability of the community and the social integration. For example, condominiums and row houses were mixed. The areas intended for mosques and primary schools were located in order to be reachable by foot in 5-7 minutes. The architecture of buildings was characterized to create a sense of belonging, as it can be seen in the projects that will be described afterwards. The third phase concerned the design of residential buildings. There are 2 typologies of residential buildings: condominiums and single-family houses. Usually, condominiums are 4-story high, have underground garages, and it is provided for the presence of shops and offices on the ground floor of some of them. The single-family houses are row houses, therefore, they have a shared wall. 44 condominium models and 7 row house models that create 67 different typologies with their aggregations were prepared to allow the identifiability of the community and the social integration. It was thought of combining different colors for facades with the different building typologies. Like this, the city will have a truly unique look. The design of condominiums and row houses was prepared in compliance with all the regulations concerning disabled persons, access ramps, possibility of installing elevators in all the condominiums, and so on. The design of building structures was made using aero codes with the parameters of seismic areas. The designers proposed to implement condominium structures with a semi-prefabrication technology that allows to speed up the construction, to improve construction features, to reduce the wastage of material. All this is in line with the criteria of sustainability. The precast elements are multi-story columns, beams, and predal type floor slabs. The final result is a traditional structure formed by precast elements. The designers defined the elevations of buildings in relation to the local roads and designed the ramps to access condominium garages. The following criteria were used to reduce energy consumption and improve the quality of life in housing units: the insulation of the building envelope, walls, roofing, ground floor, and so on. The installation of low-E glazing that allows to reduce the transmission of the solar radiation, maintaining the transmission of the visible light, as well as the installation of solar shadings if needed. The natural ventilation was implemented, designing the housing units of condominiums with 3 free facades and the row houses with 2 opposite free facades. The installation of low consumption and high efficiency equipment. The installation of noise protection systems, sealed external doors and windows, floor insulation mats, insulation of the internal walls between apartments and between bedrooms, and so on. The projects of systems and installations were prepared in compliance with energy efficiency and with the criteria that allow also disabled people to use the equipment. They include the heating and cooling system of different typologies, the electricity distribution system, the lighting system, the earthing system that is essential for the safety of residents, the lightning protection system, the auxiliary systems, telephone system, centralized TV system, intercom system, the plumbing and drainage system that includes the system for the distribution of hot and cold water, as well as the system for the drainage of used water, methane gas distribution system. The design of condominiums complied also with firefighting regulations. The fourth phase concerned the design of the infrastructures of the new city, including the main roads of the whole city and the local roads of districts that are designed after the approval of district distribution master plans, the master plan of fall sewers that provides for their working by gravity, and a pumping station to the north of the city, from which sewage will be pumped to the treatment plant located to the southwest of the new city. The master plan of storm sewers, consisting of a series of underground pipes within districts and road ditches outside districts that convey rainwater to a storage basin to the north of the city. The stored water shall be used for irrigation purposes. The master plan of the water supply system that provides for the distribution under pressure of the water stored inside a tank with suitable capacity fed by Marawa wells. The master plan of gas that, while waiting for the city to be fed by the regional network, provides for the distribution of propane air that has the same features of methane and can be easily produced mixing air with propane. Propane will be stored inside tanks placed in every district that will be removed when methane will be supplied. The master plan of electricity distribution that allowed to identify the position of transformer cabins, then positioned in the master plans of the different districts. The designers carried out the design of the public lighting network to define the position of lighting poles, especially along the local roads. The master plan of telecommunications. Thank you for your attention and greetings to the attendees.